Your wrap up and your review for your 1 to 4.3 quiz are the same thing. Okay. The first section we're just evaluating. We're going to use f of x to start with. F of x is going to equal -3 to the power, or -3 times 2/3 to the power of x. If we look at number 1, this is going to give us f of -1. This is going to equal -3 times 2/3 to the power of -1. If we have the power of -1, it flips that fraction that it's attached to. So that's going to be f to the -1 is equal to -3 times 3/2, which is just f of the -1 is equal to -9/2. It tells us to round to 3 decimal places, so we got to put this in decimal form. So it's going to be f of -1 is equal to -4.5. You can use your calculator for this. You don't need to if you don't have one. It's easy. But like I said, you can use your calculator for it. For 2, you have f of 0.35. So for this one, we're going to plug the 0.35 in for x. So that's going to be -3 times 2/3 to the power of 0.35. If you use your calculator correctly, you should get that f of 0.35 is equal to -2.603. For number 3, you have f of -5/7. So we're going to still use the -3 times 2, let's do this, equals -3 times 2/3. Now it's going to be to the power of -5/7. So f of -5/7 is equal to -4.008. For number 4, we have f of the square root of 3. So this is going to equal the -3 times the 2/3 to the power of the square root of 3. Using your calculator, you get that f of the square root of 3 is -1.486. And then number 5, we're doing f of pi. So it's going to equal -3 times 2/3 to the power of pi. We use our calculator. We get that f of pi is -0.839. We're going to scroll back up. And now we're going to use the function g of x is equal to -5/4 times 3 to the power of the opposite of x plus 2. The first one that we're going to work with is g of -2.4. So this is going to equal -5/4 times 3 to the power of the opposite of -2.4 plus 2. So if you type this into your calculator correctly, remember you can also simplify these negatives to be a positive. The double negatives equal a positive. So that's going to be -5/4 times 3 to the power of positive 2.4 plus 2. So that's going to give us g of x, or g of -2.4, is equal to -157.124. For number 7, we have g of the negative square root of 2. So this is going to give us -5/4 times 3 to the power of the opposite of -square root 2 plus 2. Again, double negatives turn into positives. So when you go to plug this into your calculator, you can just do the square root of 2 plus 2 in your power. And that's going to give us g of the negative square root 2 is equal to -53.199. For number 8, we have g of 2/5. So this is going to give us -5/4 times 3 to the power of -2/5 plus 2. So if we use our calculator, we have -5/4 times 3 to the power of -2 over 5 plus 2. And this gives us negative 7.249. For number 9, we have g of 7. So this is going to give us g of 7 is equal to negative 5 over 4 times 3 to the power of negative 7 plus 2, which is negative 5. So g of 7 is going to equal negative 0.005. And lastly, we have g of pi. So this is going to give us negative 5 over 4 times 3 to the power of negative pi plus 2. Using your calculator, if you type everything in correctly, you should get negative 0.357. If we look at the second page, the first thing on that second page tells you to describe the transformations. With these, you have to remember what we did in the beginning of the year with the transformations. If we had things in front or at the very end, they were happening vertically. If we had things in parentheses, so in this case, it's going to be in the power. If it's in your exponent, it's happening horizontally. If it happens horizontally, think opposite. So like your reflection or your compressions and stretches, take the reciprocal of the number that's in front of x in the power, and then see whether or not it's a stretch or compression horizontally. Remember, the factor is your reciprocal. Same thing with a plus number or minus a number. Take the opposite of that plus number or minus number in the power, and then it's telling you right or left. Okay? If we look at number 11, we have f of x is equal to 5 times 2 to the power of x plus 1. That 2 that's in the parentheses is your base. It has no bearing on your transformations whatsoever. Okay? That 5 in front, start with that. It's happening vertically. It's bigger than 1. So you have a vertical stretch by a factor of 5. Next part that you have to look at is that plus 1. Take the opposite of that. That's negative 1. Negative 1 tells you that you're going to the left 1 unit. For number 12, you have g of x is equal to 1/2 times 2 to the power of negative x plus 3. The 1/2 that's in front, it's happening vertically. It's less than 1, greater than 0, so that's a vertical compression by a factor of 1/2. Next, that 2, that's your base. Don't worry about it. Move on. You have a negative x plus 3 in your power. The negative that's in front of the x tells you that you reflect horizontally. If you reflect horizontally side to side, you reflect over the y-axis. Lastly, you have that plus 3. It's in your power, so think opposite. That would turn into negative 3, which means you're going to the left 3 units. For 13, you have f of x is equal to negative 4 times 2/3 to the power of 3x minus 7. Start from the very far left. You have a negative that starts this, so you are reflecting vertically. If you reflect vertically, you reflect over the x-axis. Then you have that 4. That 4 is greater than 1, and it's in front of your base, so that's a vertical stretch by a factor of 4. Next, you move to your power. That power is 3x, because the 2/3 is your base, you don't work with it. Leave it alone. The 3 that's in front of your x, take the reciprocal of that. It's 1/3. 1/3 is less than 1 but greater than 0. So that's a horizontal compression by a factor of 1/3. Lastly, you have that minus 7. The minus 7 just tells you that you go down 7 units. For 14, we have g of x is equal to 5/4 times 1/3 to the power of x plus 6 minus 1. First thing that you see there is that 5/4. That 5/4 is greater than 1. So you have a vertical stretch by a factor of 5/4. The 1/3 is your base. Don't work with it. Move to your power. In your power with that x, you have a +6. So take the opposite of it. It's going to be -6, which means we're going to the left 6 units. Lastly, we have the -1. It's a whole number. It's last. So we go down 1 unit. For the next section, you are working with exponential and log functions, and you're finding the domain, the range. If it's a log function, your vertical asymptote, which comes from the parentheses. Set up what's in parentheses equal to 0, then solve. If you are working with your exponential functions, you're going to find the horizontal asymptote, which is your vertical shift up or down, and then your y-intercept. Remember your y-intercept, you're plugging in 0 for x, solving for y, and then using that to give the ordered pair 0, something. Remember, log and ln functions are practically the same thing. Log and ln functions are reciprocals of exponential functions. So with exponents, you're going to have your domain that's automatically all real numbers, which means in your log functions, your range will be your all real numbers. If you look at number 15, you have h of x is equal to log 4 of -6x plus 5. We got a log function here, which means your range is automatically all real numbers. So from -infinity to +infinity. Your log function starts off looking more like this. Do you have any kind of reflections happening here? You have a negative in front of that 6 inside the parentheses, so it's reflecting side to side. So this is going to become this. So that's what you're going to look at for your domain. Remember, your domain are your x values. So when you look at your domain, it's the x values that go to -infinity. So you're going to start that at -infinity and go up to a specific number. That number is going to come from your vertical asymptote. Vertical asymptote comes from what's inside the parentheses. Inside the parentheses, you have that -6x plus 5. Set that equal to 0 and solve. So from here, we're going to move that 5 over, subtract it from each side. It gives you -6x is equal to -5. Then divide each side by the -6, and that gives you x is 5 over 6. So your vertical asymptote is x is equal to 5 over 6, which means your domain goes from -infinity up to +5 over 6. You have those 3 things that it's asking you for. That's all you need. For 16, you have g of x is equal to -ln of 5x minus 1. ln and logs are the same thing. So ultimately, it starts, like a function that looks like this. Okay. If you look here, you do have a negative in front. So that means that you're reflecting vertically. So it becomes this. Okay. Automatically range -infinity to +infinity since it's a ln or a log function. From there, in order for you to find your domain, you need your vertical asymptote. Take what's inside your parentheses, the 5x minus 1, set it equal to 0, and solve. Add your 1 over. You have 5x is equal to 1. Divide each side by the 5. You get that x is 1/5. So your vertical asymptote is x is equal to 1/5. Your domain involves your vertical asymptote and what your graph of your line lastly looks like. You had that reflection, so this is going to the right for your domain, so it goes to +infinity. So your domain includes the vertical asymptote number and the +infinity. So that means that we're going from 1/5 to +infinity. For number 17, you have h of x is equal to -6 times 3 to the power of -2x plus 1 plus 8. For this one, that 3 is greater than 1. So it's going to look similar to this. You have a negative there, though, in front of the 6. So it reflects vertically across the x-axis. So it's going to turn into that pink one. Automatically, your domain, negative infinity to positive infinity. Your range, you are going to first find your horizontal asymptote and use that number and the last part of what the line looks like in order to find your range. Your horizontal asymptote comes from that plus 8. So y is equal to 8. If you look at that line, it goes to negative infinity. It goes down. So if it goes to negative infinity, your range is from negative infinity up to the number from your horizontal asymptote, which is 8. Lastly, your y-intercept. Plug in 0 for x, solve for y, give the ordered pair 0, something. So we're given the function negative 6 times 3 to the power of negative 2 times x, which is going to be 0, plus 1, plus 8. This is going to simplify to negative 6 times 3 to the power of 1 plus 8, because negative 2 times 0 is 0, and 0 plus 1 is just 1. 3 to the power of 1 is 3, so negative 6 times 3 is negative 18, plus 8 is negative 10. So that's the y-intercept, 0, negative 10. For 18, you have g of x is equal to 5 times 2/3 to the power of x plus 7 minus 4. That 2/3 that is your base tells you what your line looks like. It's going to go down from left to right. So you have no reflections happening here. Your line's going to stay looking the way that I just drew it. Automatically, your domain, since it's an exponential function, is from negative infinity to positive infinity. Your range, you need your horizontal asymptote first. You have that minus 4, so y is equal to negative 4. This graph or this line is going down. Or sorry, no, it goes up. It goes up, not down. It goes to the right and up. So if it goes up, it goes to positive infinity, which means our range is going to go from negative 4 to positive infinity. Lastly, find your y-intercept. Plug in 0 for x and solve. This is going to give you 5 times 2/3 to the power of 0 plus 7 minus 4. You simplify this to 5 times 2/3 to the power of 7 minus 4. You're going to have to use your calculator. So 5 in your calculator. 5 times 2 over 3 to the power of 7, go down, minus 4 is negative 3.707. So this is going to be the y-intercept of 0, negative 3.707. For the next part that we're going to go over, we're rewriting log functions to exponential functions and vice versa. So if we look at number 19, we have log 7 of 3 is equal to x. If we write this in exponential form, we're going to get rid of that log, bring that 7 up. The 3 is going to become our answer, and the x is going to become our power. So we're working counterclockwise. So this is going to give us 7 to the power of x is equal to 3. For 20, you have 1 over 49 to the power of 5 is equal to y. In this case, you're going from exponential form to log form. So that 1 over 49 is your base. It's going to stay your base on your log, so it's going to drop down to be that subscript number. The 5 is going to become your answer. The y is going to become your big number on the other side of that equal sign. We're going to add in the word log there, and this is going to give us log 1 over 49 of y is equal to 5. You do not need to put the parentheses around the y after the log 149. However, you need to make sure that y looks like a whole number or a whole part, not a subscript part. If it looks like a subscript part on your quiz, it's going to end up being marked wrong. Same thing with that 1 over 49. Make sure it's lowered and it's little, so that way it's a subscript. If it's not and it's a whole number, it's going to take it to where you have the base of 10, which gets into number 21. When you don't have a base on a log, automatically it's 10. So for 21, it gives you log 4 equals x. Log 4 is the same exact thing as saying log 10 of 4 is equal to x. So if we get rid of that log, bring that 10 up, and work counterclockwise, the x is going to become our power, the 4 becomes our answer. So that's going to give us 10 to the power of x is equal to 4.
And that's when there's no number under the log.
That's when there's no number attached to the log for its base. Yep, it's automatically 10. For your next section, you're rewriting and evaluating. For 22, it gives you 3 to the negative 5th power is equal to x. If we rewrite this, it's the same exact thing as saying x is equal to 1 over 3 to the 5th power. Remember, those negative powers take the reciprocal of the term that they're attached to, and then you just simplify it from there. So 3 to the 5th power is 243, so x is going to equal 1 over 243. For 23 and 24, those are given to you in log form. Rewrite them in exponential form, and it's going to make things so much easier for you. So for 23, you have log 8 of 1 is equal to 0. Or sorry, log 8 of 1 is equal to 0, but log 8 of 1 is equal to x. So this is the same thing as saying 8 to the power of what is equal to 1. Anything to the power of 0 is 1, so x is equal to 0. For 24, you have log 9 of 1 over 81 is equal to x. So again, if we rewrite this without the log and write it as exponential form, it's 9 to the power of x is equal to 1 over 81. That 1 over 81 is the same thing as 1 over 9 to the power of 2. To bring that 9 to the power of 2, the 1 over 9 to the power of 2 as a whole number, it's going to give you 9 to the power of x is equal to 9 to the negative 2nd power. Your bases are the same, so cancel them out, and you just have that x is equal to negative 2. For the last part of your review, it tells you that Valentina inserts $1,500 into a savings account at an interest rate of 3.65% for 7 years. How much money is in the account under the following conditions? You have compounded monthly, daily, semi-annually, and continuously. Remember, you're using a different formula for the monthly, daily, and semi-annually as you are as the continuous. The continuous one is easy. That's just A of t is equal to P times e to the power of r times t. For these ones up here that are above that, you are going to use A of t is equal to P times 1 plus r over n to the power of n times t. Remember, your r is represented as a decimal, and your n is your compounded monthly, daily, semi-annual. So for all of these, your P is the 1,500, your R is going to be 0.0365, and your T is 7. If we are compounded monthly, your N is going to be 12. So this is going to give you A of T, so A of 7. A of 7, that's your time, is equal to P, which is 1,500, times 1 plus your rate as a decimal, so 0.0365 over n, which is 12, to the power of n, so 12, times t, which is 7. You're going to have to use your calculator for this. So if you use your calculator, you're going to type in the 1,500 times 1 plus 0.0365 over 12 to the power of 12 times 7. You're rounding this to the second decimal place since you're dealing with money. So that's A of 7 is equal to $1,935.91. For when you are compounded daily, your N is going to equal 365. So that's going to give you the formula A of T. So 7 is equal to P, which is 1500, times 1 plus 0.0365 all over 365 to the power of 365 times 7. So again, we're just going to use our calculator with this. Round to the second decimal place. So 1500 times 1 plus 0.0365 over 365 raised to the power of 7 times 365. Round to the second decimal place, you get $1,936.64. Next, you have compounded semi-annually. Remember, semi-annually is twice a year. So if you're semi-annually, your N is going to equal 2. So this is going to give you A of 7 is equal to 1500 times 1 plus 0.0365 over 2 to the power of 2 times 7. So use your calculator. 1500 times 1 plus 0.0365 over 2 to the power of 2 times 7 is 14, gives you A of 7 is equal to $1,932.20. Your last one, it tells you that you are compounding continuously, so you're using that APERC formula. A of T is equal to P times E, that's in your calculator, to the power of R times T. We said that P is 1500, R is 0.0365, and T is 7. So if we pull this all into our formula, it's going to be A of 7 is equal to 1500 times E to the power of 0.0365 times 7. Again, we round to the second decimal place since we're dealing with money. And this gives us $1,936.66.